we need to find the complete integral of this equation. For that we need to take this one to the other side, and I'm writing here p plus y whole square plus q plus x whole square minus 1. And then we need to find all these details. What is fx? It is the derivative of f with respect to x, so that is 2 into q plus x. And fy is the derivative of f with respect to y, so it is 2 into p plus y. And fz, because there is no z, so it is 0. And fp is twice of p plus y, and fq is twice of q plus x. Now we are going to use the Charpit subsidiary equations. Let's put all these details in these equations. Okay, so this is dx divided by fp. fp is twice of p plus y, so it is twice of p plus y equals to dy divided by fq. It is twice of q plus x equals to dz divided by p multiplied with fp. This is your fp, so it is twice of p into p plus y plus q multiplied with fq. This is your fq, so it is twice of q into q plus x. And then is dp divided by negative of fx. What is fx? It is twice of q plus x, so twice of q plus x plus p multiplied with fz. fz is 0, so there is no need to write the another term. It is negative of twice of q plus x. And then dq divided by negative of fy is twice of p plus y, and again q multiplied with fz. fz is 0, so that's it. And now we need to choose the ratios which are easier to solve, so that we can get the value of p and q, or the relationship between p and q. So let me choose the ratio, the first and the last one. I'm having the same denominators here. There is also a negative sign because of this, right? Okay, so when choosing these two ratios, 2 into p plus y cancelled out with this, right? So these two cancelled out, and we are getting dx is equal to minus dq, or dx plus dq is equal to 0. Integrating both the sides, we get x plus q equal to a, where a is a constant. Very fine. How to get the value of p and q from this? What is our given equation? This is the given equations. Let's use this equation. So the given equation is p plus y whole square plus q plus x whole square equal to 1. So let's put the value of q plus x over here. So this is p plus y whole square plus q plus x is a, so this is a square equal to 1. So we are getting p plus y whole square to be equal to 1 minus a square, and p plus y is equal to square root of 1 minus a square. That is, the value of p is square root of 1 minus a square minus y. Now to get the value of the complete integral, we need the value of z. So dz is equal to p dx plus q dy. This we know that. Let's put the values p and q over here. So we have this to be square root of 1 minus a square dx minus y dx plus what is q? It is a minus x. So this is a minus x dy. We can also write this as this first term minus second term plus this will be a dy minus x dy. Collecting these two together, we have this first term plus the third term, and now taking negative outside, this is y dx plus x dy. I'm going to take this bracket to the left hand side. How can I write this left hand side to be? It is a derivative of z plus yx, isn't it? Right? And writing this as it is, plus a dy. And now it is very easy to integrate this. This will be z plus yx equal to, this is constant when integrating with respect to x, the square root of 1 minus a square into x, plus a is constant when integrating with respect to y, this is ay, plus the constant b. So this is a required complete integral of the given equation. You can also take this yx to the other side to have only z in the left hand side. It's your choice. Alright, thank you.